What I want to show you is two more types of things because this is important. What we've been looking at are called single bonds because we're sharing one electron each per orbital, per atom. What we're going to see now is a double bond, which often happens between elements. Like, for example, O2, or between what we call diatomic ions, diatomic molecules. God. Oxygen, again, is S2P4. This really won't take that much longer, folks, like maybe 3 or 4 more minutes. Here's oxygen, S2P4, as we've already looked at. There's that, and then there's that, and then there's these. So, okay, O2 is a compound between two oxygens. And I'll do the other oxygen in blue. This is oxygen number 2, which is also S2P4. And once again, the full orbitals are not going to interact. What's going to interact, though, is these two, let's call it PY and PZ orbitals, just for the heck of it. We'll say this is PX, which isn't going to do anything. But instead of just sharing one, like this is one hydrogen atom, this is another one, this is another one. Instead now, we're going to have 2 electrons shared between these 2 oxygens. And this is called a double bond because 2 electrons are getting shared from each atom. And the way you draw this, first of all, here's the Lewis dot diagram. Instead of just having 1, it's going to be 2. So it would get drawn like this with 4 electrons in between. And then the other way we could draw it is to draw it... Wait, I'm not going to do it right next to it. That's too confusing. I'll do it up here. O2. So instead of having 1 line in between, we would have... do this. We have 2, and that's representing the 2 shared electrons. And
what are we more likely to see? The Lewis dot?
You're going to see all of them. They're equally likely. On a test, do you mean like between this and this? Which are you more likely to see? Or this?
That top one.
You'll see them all in different contexts. They're used for different reasons, I think.
So would there be like
So it's still a covalent
wait.
bond?
Hold on, Lisa asked the question first. So.
Would there be a triple bond?
There is, that's what I'm about to show you. This will be the very, very, very last thing. Very, 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 very N2. All gases, basically, on the periodic table exist as diatomic molecules. In fact, there's a, it's not an acronym, but a little mnemonic device, which is, I brought Claire home on Friday night. Iodine, bromine, chlorine, hydrogen, oxygen, fluorine, and nitrogen. That's all the diatomic elements. You don't have to know that. You don't have to have that in your notes. Just know that I brought Claire home on Friday night. Don't tell my wife. Anyway, okay, here's nitrogen. Nitrogen is, as you can see, S2P3, as we've discussed. Looks like this. S2. And so, P3. And so what happens is, when we have nitrogen number 2, same thing. These 2 aren't going to interact, the 2 s orbitals aren't going to interact, but the 3 p orbitals are going to interact. Each of them is going to be sharing an electron, and this forms a triple bond, which would be written like this, or like this. Okay, so anyway, single bond, double bond, triple bond. And that
Wait, so what's the element that's in the blue?
It's the other nitrogen. So this is like nitrogen number 1, this is nitrogen number 2. So it's a diatomic molecule between 2 nitrogen atoms. Does that make sense?
Yeah.
Okay, we do this all day. Let's go. You ready?
45 minutes of sleep in class.
1, 2,
fumble
3,
that ball.
chemistry. Okay. Anyway, all right, guys. I know that's pathetic. Okay. Thank you very much for your attention.